Good afternoon, class. Welcome to our session today. Before we start, I will show you some pictures and I want everyone to observe them for a moment and tell me what are these devices and what do you think they were used for. So here are the pictures. So anyone? Yes? Alright, very good. This picture shows some of the world's earliest animation devices, and these devices were used to create the optical illusion of motion. And here are the intended learning outcomes of this lesson. Allow me to read first. First is to explain how early animation devices create the illusion of motion. Second is to appreciate the significance of early animation inventions in the development of modern animation. And last is to create a simple animation device that demonstrates moving images. So now let's proceed. First, we have the magic lantern in 1659, invented by Christian Huygens. It is the ancient ancestor of the modern projector, using a candle and lenses to project a hand-painted glass lights onto a wall. By swapping these lights, showmen could create a basic illusion of movement. And now I'm going to show you a video on how the magic lantern works. So here it is. Okay, that's it. Now, let's move on to 1825 with the thaumatrope, a popular optical toy invented by John Ayrton Paris. It is a simple cardboard disc with separate drawings on both sides attached to strings. When spun rapidly, your eyes blend the two images into one single moving pictures. And now, I'm gonna show you a video on how the thaumatrope works. So, that's how the thaumatrope works. So next, we have the phenakistoscope in 1832, invented by Joseph Plateau. This device used a spinning cardboard disc featuring a sequential drawings separated by vertical slits. To see the action move, a single viewer had to spin the wheel and look through the moving slits into a mirror. And now, I will show you a video on how exactly the phenakistoscope works.
The phenakistoscope was the first device to demonstrate the illusion of animation. Invented by Belgian physicist Joseph Plateau in 1832, the phenakistoscope was so revolutionary that it was viewed by some as witchcraft. A slitted disc with sequential images mounted on a handle. Spin the disc and nothing unexpected happened. But if the spinning disc is viewed in a mirror, the images burst into life. Viewing the discs reflect.
So that's it. That's how the phenakistoscope works. Right after, William George Horner invented the zoetrope between 1833 and 1834 to improve the mirror design. It uses a spinning cylindrical drum with a vertical viewing slits cut into the top rim. This allowed multiple people to stand around it and watch the inner paper strip come to life at the exact same time. So, I have here a video showing on how the zoetrope works. So that's how the zoetrope works. Next in line is the kineograph, invented by John Barnes-Linnet, which we commonly call a flip book. It completely removes spinning drums and mirrors, relying entirely on a small book of sequential drawings. When you flip the pages rapidly with your thumb, the rapid succession of images creates fluid motion. And here is the video showing how the kineograph works. So that's how the kineograph works. Moving ahead to 1877, where Emil Renaud invented the praxinoscope, which was a major upgrade to zoetrope. He removed the viewing slits entirely and replaced them with a central ring of angled mirrors. These clever changes give the viewer a much brighter, sharper, and clearer animation look. So now I'm gonna show you what the praxinoscope exactly looks like and how it works.
The praxinoscope, invented in 1877, was the successor to the zoetrope. The praxinoscope replaces the zoetrope slits with angled mirrors placed in the center of the drum. Viewing the spinning animation reflecting off these circularly arranged mirrors breaks up the blur of color into an
So that's how the praxinoscope works. Following that, Edward Muybridge introduced the zoopraxiscope in 1879, a vital precursor to the movie projector. Instead of using hand-drawn cartoons, it took actual real-life photographs captured by a sequence of cameras, placed them on a rotating glass disc, and projected them to recreate true movement. So here is the video showing the zoopraxiscope works.
This is called The Horse in Motion, and it is considered the first motion picture ever made. In 1878, Edward Muybridge lined up a series of cameras, each with a tripwire connected to the camera shutter. As the horse named Sally Carter tripped the individual wires, the camera snapped an image of her in full stride. The significance of the experiment settled a long debate over whether horses lifted all of their hooves off the ground during their run.
So that's how the zoopraxiscope works. Finally, our last device is the theater optic, also invented by Emil Renaud in 1879. This was a massive scale-up of his mirror system that used long spools of transparent, hand-painted film strips containing up to 700 frames. By projecting these strips, Renaud held the very first extended animated show for large public audiences. And now I will show you how the theater optic works.
As figured, at last it happened. The short picture strips have been expanded to a long band, containing 500 animated slides drawn on transparent gelatin. All holes run between each image, foreshadows perforations on modern film. Each hole measures into the teeth of the large wheel, rotating at the same speed.
So that's how the theater optic works. So as you can see, those 8 early animation devices relied on deceiving on our eyes and brains using fast repetition, lighting, and persistence of vision to build the foundation of cinema. So now that you already have enough knowledge about the 8 early animation devices, let us proceed to our activity today. I will group you into 3 groups, Group 1, Group 2, Group 3, and here is the instruction. Students will create a working model of an early animation devices. You can choose one of those 8 early animation devices that mentioned earlier. And later, you will choose a representative that presents your output here in front. Okay, you can start now. And if you have any questions, just raise your hand. Okay, time's up. And now, let's have a quiz. I have here a summary matrix, but before that, I want everyone to read first the instruction. So, everyone, can you read? Okay, then you can start answering now. Okay, time's up. Done or not done yet? Submit all your answers in the Google Classroom. That would be all for today, class. I hope you learned a lot.